Hi, my name is Dylan Horton, and along with Jose Gutierrez and Gage Standard, I worked on performance analysis of PQC KEM algorithms. So what are these algorithms? So PQC algorithms are algorithms that are resistant to quantum attacks. And that's important because a lot of public key cryptography currently, like RSA, is vulnerable to these attacks. And given the development of a large enough quantum computer, they become weak enough that they could be cracked. And so we need new key encapsulation mechanisms. This is a kind of algorithm that is used to distribute symmetric keys to two parties. And so the key encapsulation mechanism algorithm is used to encrypt the key on one end and then send it over to the other party, which can decrypt it. And so we're going to be looking at the performance of these under TLS, which is transport layer security. It's a very common protocol that's used in a lot of network traffic. And we develop two programs, a client and a server, which are going to initiate a TLS handshake. That's the beginning of a communication. There's a TLS handshake so that they can exchange symmetric keys for the rest of the communication. And we do that through our PQC KEM algorithms. And we're going to be testing 5 of these algorithms. And we're testing their key pair generation, how long it takes to generate the key pairs, how long it takes to encrypt data, how long it takes to decrypt data, and the overall performance of the TLS handshake. So here's some of the results that we have. This is focused on the results from the TLS handshake. So on the left, we have the average handshake time that it takes for these algorithms, which was pretty similar across most of these algorithms. The only one that was significantly worse was HQC. And on the right, we have the bandwidth usage that each of these algorithms. So that's how much data was needed to be sent and received in order to perform the handshake. And the best ones that formed out of this are Kyber and ML-KEM. Now, this is important, the bandwidth usage, because there's a lot of these handshakes going on. And you don't want these handshakes to be clogging up your network bandwidth. And a higher amount of data usage is also going to lead to poor performance when you have worse network conditions. So some future work that we could do. So we could test the performance under different network conditions. So right now, the only thing we have testing is in a local environment. There's no communication over a network. So we could test it in different network conditions to see how that impacts the performance. And we could also test the performance of hybrid PQC algorithms. These are algorithms which combine the post-quantum resistant algorithms with more classical algorithms that have, in general, greater efficiency during certain parts, which allows, and so it could be good to test those algorithms. Thank you for your time.